So my name is Nathan Eagle. I'm affiliated with MIT and the Santa Fe Institute. And I guess I'll be talking about cell phones as sensors. Maybe backing up a little bit, I can talk a little bit about what I did my dissertation research on. And that was, what we did is we gave out 100 cell phones to people at MIT. And most of them were working in the same building. And the cell phones, they work like normal phones, but the only caveat was that they had this basically Uber spyware on it. And what it did was it started on boot, was invisible to the user, and it logged everything. It logs communication, so where these subjects go. It logs proximity, so it did continuous Bluetooth scans to start figuring out who's proximate to whom and when. Obviously, we're getting communication, SMS, that sort of thing. So the subjects had to sign really, really thick subject consent forms to agree to participate in the study, and they were very aware that this data was being captured on them. But what happens is when you start getting this really rich behavioral data about a large group of people, you can start basically putting this data into these machine learning models that can do behavioral prediction, and prediction on both an individual scale as well as a dyadic scale, so pairs of people inferring things like relationship, predicting what you're going to do with another person when. And then perhaps most interestingly, looking at aggregate dynamics, so looking at how the ebbs and flows of the organization and what the organization is responding to in terms of external events. And you can start thinking about these things as organizational rhythms. So, so that's at least how we were turning a mobile phone into a way to gain insight into the underlying dynamics of a social organization, essentially using the mobile phone as a sensor. I can go into the specifics about building these mathematical models. I mean, for things like the individual behavior prediction, we were able to kind of start showing, and it's not sophisticated stuff really. I mean, look, we're building these condition hidden Markov models to start looking at extracting patterns of a single user's life or single individual's daily behavior. So, you know, at 8 o'clock or 9 o'clock, you know, you could see my phone the alarm would go off. I'd push snooze maybe 5 times, and then eventually I would roll out of bed, and you could see me kind of making my way to my office at MIT, and then as more and more people come in, you could start seeing that type of proximity dynamics, and then I'd go off with 1 or 2 individuals for lunch. You could see me leaving campus, and then if you were watching me for 9 months, you would be able to get a pretty good sense of, you know, who am I going to have lunch with tomorrow. I mean, it's not that difficult. We are creatures of habit, and so building a mathematical model that can start predicting it, while it sounds kind of cool, like, wow, I can predict who you're going to have dinner with and what time. You know, it's not that sophisticated. But so that's what we're doing on the individual level. On the dyadic level, so we're being able to start inferring relationships based on things like proximity. And again, this is kind of common sense. I mean, if we're proximate, if I'm proximate to an individual at the coffee machine on Tuesdays in the afternoon, and I'm a lot of proximity, and that corresponds to one type of relationship. But if I'm proximate to that person in downtown on a Saturday night at like 3 in the morning, that corresponds to a much different relationship. And again, so this gets teased out of the data very easily. And what we were able to show is that based on just the proximity data, we were able to infer the social network topology within 96% accuracy, meaning we could predict who's friends with whom based on this kind of these salient behavioral signatures. So that's dyadic, and then lastly, this kind of aggregate dynamics, or looking at organizational rhythms. And in this case, this was done at the MIT Media Lab, and the lab kind of lives and dies by these sponsor weeks, where the sponsors come in and want to know, you know, how the lab is spending their money. And so the week before, or even a couple weeks before, leading up to these massive kind of showcase displays where we have to do our song and dance, the organization really kind of comes together, meaning there's more and more people spending more and more late nights in the organization, and you can see it kind of just building up to this climax of the final time where you actually have to get all your demos ready and get your stuff polished, and then so you see the organization basically getting really cohesive, and then afterwards, you know, you can see everyone kind of dispersing. Which is interesting. The other things we were gathering were things like what happens when the Red Sox win the World Series. We could look at like these outlier behavior events of people kind of basically doing things that are totally not what the norm is. And so if enough people, if our algorithm misses on enough people, we think something really happens. So none of these people are going to dinner when we thought they were going to dinner. Everyone's flooding into downtown Boston. Something has happened. on a kind of more regular schedule, we can actually start, one of the other things that we're doing is we're putting these little Bluetooth beacons, we call them BlueDAR. And what the beacons we're doing is they're just doing continuous Bluetooth scans of any visible MAC address. And so when you're scanning for all these people all over campus, in this case we're putting some of these things in Boston as well, you can do things like figure out how fast the average person is walking as they're walking down the Infinite Corridor, for example, at MIT. And there's an amazing correlation between how the average speed that people walk down this corridor and whether it's finals week or whether it's Thanksgiving break. So you can actually start looking at how the aggregate in this case is responding to these externalities. So that's again kind of how we're repurposing the phone here as a way to gain insight into this kind of diverse and complex social system.